Knowing about particle accelerators is important, crucial, before we get into the news. The largest and most potent particle accelerator in the world, the Large Hadron Collider, CERN's LHC, is a 17-meter wide ring of superconducting magnets. The scale of human scientific achievement is staggering. In fact, due to its potency, it can recreate the circumstances under which the universe was created. But could this device, which was created to uncover the universe's secrets, hold the key to something much more sinister? CERN was established in 1954 and has since been one of the most prestigious research organizations in the world, with 23 member states and thousands of scientists. It is a center for cooperation and innovation. Although the LHC is CERN's most important project, it is just a small portion of an extensive network of experiments and accelerators. Consider a competition not of vehicles or horses, but of subatomic particles, competing against time and space itself. The LHC accelerates protons to almost the speed of light, sending them into collisions that simulate the energy of the universe at the time of the Big Bang. These collisions generate temperatures 1,000,000 times hotter than the Sun's core. While sophisticated cooling systems keep the magnets at temperatures lower than those of outer space, the beams inside the LHC are designed to collide at 4 locations around the accelerator ring. These correspond to the positions of 4 particle detectors, CMS, ALICE, ATLAS, and LHCb. Each serves a distinct purpose in investigating various facets of particle physics, working together like enormous cameras capturing images of these collisions. Researchers then sift through the rubble for hints of the enigmatic events that reveal the fundamental elements of our universe. The Higgs boson, sometimes referred to as the God particle, is one such discovery. By examining the microcosm, we might learn more about the macrocosm. But every answer raises new questions and presents new challenges. The LHC is more than just a scientific facility, it is a monument to human ingenuity and curiosity. It represents our unrelenting quest for knowledge and our drive to understand the fundamental forces that shape our universe. But as we push the boundaries of knowledge, we must also confront existential and emerging ethical questions. What are the dangers of venturing into the unknown? Could our search for knowledge inadvertently unleash forces beyond our control? In the sacred corridors of CERN, where the limits of human understanding are continuously tested, a new discovery has surfaced, one that even makes seasoned researchers tremble. Former CERN researcher Brian Cox, a respected voice in the field of particle physics, recently made a revelation that has both enthralled and alarmed the world. Cox's comments have a strange clarity. The enormous Hadron Collider at CERN aims to replicate a miniature Big Bang. Yes, you heard that correctly. The scientist also discussed the repercussions of achieving this goal, highlighting the LHC's remarkable capabilities and its potential for new discoveries. Utilizing a condensed version of the original event that gave rise to our universe. This includes its ability to reveal Higgs boson secrets and investigate dark matter, a mysterious substance that comprises a sizable portion of the universe. The idea of conjuring the very essence of the universe and holding the power of creation in our hands is both exciting and dangerous. The mini Big Bang is more than just a theoretical concept, it is a concrete reality inside the LHC. The temperatures, pressures, and raw energy resemble the conditions of the universe's infancy. It's like witnessing the birth of existence itself, at the dawn of time. However, with such power comes great responsibility. Back in 1978, Russian physicist Anatoly Bugorsky was working on the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, when a system flaw caused his head to accidentally enter the path of a proton beam. The beam passed through his head with unimaginable force, entering through the back of his head and exiting through his nose. Bugorsky experienced a surreal moment. He saw a flash as bright as 1,000 suns. Yet he felt no pain. He remained conscious, kept his eyes open, and even walked himself to the hospital. The beam had burned through bone and flesh, leaving a trail of destruction. The incident was both terrifying and fascinating. It was not only a personal tragedy but also a stark reminder of the immense power and potential danger of particle accelerators. The path of the beam caused localized tissue death, resulting in hearing loss and partial facial paralysis. Yet remarkably, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. One of the significant dangers of particle accelerators like the LHC is the potential for unforeseen reactions. Some scientists have expressed genuine concerns about manipulating or warping space and time. Not as science fiction, but as a theoretical possibility. One of the most interesting and troubling issues is the possibility of creating a microscopic black hole. The idea that the LHC could create a black hole, even on a minuscule scale, is alarming to both the public and experts. Although CERN scientists have assured the public that such black holes would be unstable and would evaporate almost instantly, the mere possibility has sparked debate, fear, and awe. Black holes are cosmic phenomena with gravity so intense that not even light can escape. They consume stars and distort the very fabric of space. To simplify the concept of what might happen in a particle accelerator, when protons collide with near light-speed energy, spacetime may bend, like a trampoline under extreme weight. If that weight is great enough, a deep depression forms, from which nothing can escape. This is a crude metaphor, but it illustrates the potential risks. In the LHC, where the laws of the universe are both strange and exquisite, there exists a theory that additional dimensions may lie within our reality. If so, the LHC's collisions could tap into these dimensions, forming a gravitational funnel and, possibly, a microscopic black hole. Even some prominent scientists have begun paying close attention to this mysterious and powerful particle dance. Most notably, several theoretical physicists have speculated that these events may not only open temporary gateways to higher dimensions but also provide a glimpse into entirely new physics, phenomena beyond the standard model. This leads us into uncharted territory, where the known laws of nature begin to blur, and speculation becomes as vital as calculation. Are we simply unraveling the mysteries of the universe, or are we tampering with forces we do not fully comprehend? One theory gaining traction among fringe scientists and even a few mainstream researchers is that the LHC could inadvertently create conditions ripe for a dimensional breach. A rift in the fabric of spacetime, allowing matter or even entities from beyond our perception to cross into our reality. While such claims often sound like science fiction, history has shown that today's impossibilities may become tomorrow's breakthroughs. Quantum entanglement, time dilation, and the photoelectric effect were once considered outlandish, yet now form the basis of technologies and theories that define our modern world. Still, as we probe deeper, ethical dilemmas surface. Should humanity risk creating phenomena it cannot reverse in the pursuit of knowledge? Is there a point at which our quest for discovery becomes a threat rather than a triumph? These are no longer hypothetical questions. In 2012, when the Higgs boson was finally discovered, the world applauded. But behind the scenes, many physicists were struck by how easily the experiment could have gone differently. A minute change in variables could have caused unexpected results. In rare, extreme scenarios, the amount of energy released in high-speed collisions could theoretically destabilize vacuum states. A process known as vacuum decay, where the very fabric of the universe could be torn apart and reassembled under new laws of physics. Though such events are statistically improbable, the mere existence of the possibility urges caution. What's more unsettling is that many of these theories cannot be tested without enacting them. We are, in essence, learning by doing, with stakes that are cosmic in scale. Meanwhile, inside the control rooms of CERN, thousands of scientists, engineers, and technicians continue their work, analyzing petabytes of data. Looking for signatures of supersymmetry, hints of dark energy, or ripples that may indicate a breach in known dimensions. Among the researchers, there's a strange mix of awe, pride, and trepidation. The LHC represents not just the frontier of physics, but the frontier of human will, the desire to know, even at the risk of what might be unleashed. Brian Cox and others urge the public to stay informed, not alarmed. They emphasize that scientific discovery has always involved risk, but also remind us that every major leap in knowledge comes with a cost. Sometimes that cost is financial, sometimes emotional, and sometimes existential. As the LHC prepares for new runs at even higher energies, and as additional upgrades push the machine further into the unknown, one can't help but wonder, will we finally uncover the theory of everything? Or will we open doors we were never meant to touch? In his book, the late Stephen Hawking forewarned of a scenario in which the Higgs boson may become unstable. Extremely high levels of energy instability could result in a catastrophic vacuum decay, a cosmic event that would wipe out not only the Earth but the entire universe. In his book on the possibilities for mankind, renowned British cosmologist and astronomer Sir Martin Rees also expressed his concerns regarding the experiments carried out at CERN. He examined the possible dangers connected to particle accelerator operations, including risks to CERN employees. His remarks were more than just a warning, he was filled with existential dread. The worst-case scenario was described, in which a botched experiment might produce a state known as vacuum instability. This instability might theoretically cause a phase transition that would reverberate throughout spacetime, resulting in a cosmic catastrophe that could consume the universe. Rees's worries went beyond merely theoretical considerations. He gave these disastrous consequences a real possibility, despite being slim, and asserted that even a minuscule chance ought to bring us to a halt. The margin of error is very narrow, and the stakes are unthinkably great. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible exploration, recognizing that there are numerous fears and concerns surrounding the LHC's activities. He emphasized that there are rigorous safety measures in place, with thorough procedures and reviews to ensure the LHC's operations are carried out with the utmost care. Cox reassured that the energies involved are within the bounds of what the Earth naturally encounters, and the likelihood of developing a stable black hole is astronomically low. Even if one were made, according to scientists, it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon that Stephen Hawking predicted, known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone one step further and speculated that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What kind of reality might we accidentally release? Unknown forces or entities? How did this notion originate, and what does it represent in the context of scientific investigation? The concept of creating a door to hell has even been sensationalized in the media, which has fueled the blaze of ambiguity. In string physics, the theory of parallel dimensions is not new. One of the leading candidates for a unified theory of everything suggests that space may have more dimensions than the three we are familiar with. These additional dimensions could be compressed or hidden from our perception, but under extreme circumstances, they could theoretically be accessed or revealed. Now picture the LHC as a cosmic key that unlocks doors that have been sealed since the beginning of time. When protons collide at energies previously unattainable on Earth, this could theoretically result in ripples or holes in spacetime's fabric, creating temporary portals or access points to these hidden realms. While much of this is still confined to science fiction, it's difficult to ignore the weight of possibility. At the center of this debate is the question of responsibility. Should we be tampering with forces that could potentially alter the fabric of reality itself? With the LHC's ability to investigate the deepest corners of existence, should we be worried about what we might discover? As Brian Cox and other scientists continue to explore the mysteries of the universe, one thing is certain: the pursuit of knowledge comes with risks. The quest to uncover the unknown is fraught with both visible and invisible threats. The story of the LHC is more than just a tale of cutting-edge science. It is a narrative of humanity's unquenchable thirst for comprehension. With each experiment, every new thing that the universe reveals is becoming increasingly intricate and surprising in ways we did not expect. But the question remains: when we unlock the deepest secrets of the universe, are we ready for the consequences? Or will we, like Anatoly Bugorsky, find ourselves standing at the edge of the unknown, peering into a universe that we may not fully understand or control? The future raises a question filled with both danger and opportunity. As we stand on the precipice of discovery, we must ask ourselves: are we truly ready to face what we might unleash? This is not a call for fear, but a reminder of responsibility. Scientific advancement has always walked a fine line between progress and peril, from the splitting of the atom to the decoding of the genome. With each leap forward, humanity has been granted unprecedented power, and with it, the burden of wisdom. The Large Hadron Collider is a marvel of human achievement, a testament to our capacity for collaboration, ingenuity, and ambition. It has already yielded profound insights: the confirmation of the Higgs boson, the advancement of quantum field theory, and new windows into the fundamental forces of nature. Yet, with such power, the questions grow heavier. What lies beyond the known? What laws still govern us in the shadows of our understanding? Critics argue that some boundaries should remain uncrossed, that certain experiments test not only physical limits but ethical ones. Is there a point where curiosity must yield to caution? Where the sheer scale of what we might disrupt outweighs the thrill of what we might discover? And yet, progress rarely waits for permission. Throughout history, those who questioned, who dared, who reached into the void, have reshaped the world. The challenge, then, is not to stop reaching, but to reach wisely. To construct a future where discovery is guided not just by intellect, but by foresight. In the end, the true question may not be whether we are ready to face what we might unleash, but whether we are prepared to live with the answers we find. Because in our pursuit of the unknown, we are not just exploring the universe, we are revealing who we are. Are we conquerors of nature, or its stewards? Are we reckless architects, or careful custodians? The LHC does not only collide particles, it collides our ideals, fears, hopes, and responsibilities into one narrow beam of light hurtling through the darkness. And what we find at the end of that tunnel may redefine what it means to be human.